approximations when the curve is under the x-axis is going to be very, very, very similar to what we did above. The only difference is now that the value of the function is going to be negative. We're going over a question like this. You usually don't see a lot of these if you were to Google approximating the area under the curve, because this really will come more into play when we start dealing with integrals, but it's about to start to get used to dealing with negative values for functions. So again, the curve is given to you. We have screenshotted it and provided it, and we're trying to approximate the area under the curve from -6 to 6. So remember, we are using rectangles here in each of these cases because specifically we're referring to a Riemann approximation. And in this case, we want 3 equally spaced subintervals, or 3 rectangles. That means that delta x, or the height of each of those rectangles, is going to be 6 minus a -6, that's your b minus a, over how many rectangles we have, or 3. So in this case here, we are going to have 4, okay, because it's 12 divided by 3, or 4 is going to be the width of each of those rectangles. So if I'm starting at -6 here and I go over 4 units, that's going to stop me at a -2. That was -6. And if I go over 4 more units, that brings me over to 2. And if I go over 4 more units, that brings me to a +6. So notice here, if we're using, again, your left-hand approximation, I'll do it again in blue here, the area under the curve, using your left hand for each of those, is going to be, for the first subinterval, starting at -6. So the height of our function is 0, because we're using that left-hand approximation. When I go to the next subinterval, okay, using there the values from -2, notice the height of the function is all the way down here. So this is the rectangle. Sorry about that. This is the rectangle that we're using, the one that's coming from the left-hand side of our function from that endpoint and continuing through to the other end. Notice again for the last subinterval we're using again f of 2. And here is our last rectangle. Notice that this rectangle goes beyond our curve or outside our curve, and that's okay. So remember, from when our function was decreasing, we have here under approximations, but we have here when it's increasing, okay, that over approximation on the other side. So again, because these are rectangles, we have delta x, but we're just going to use the value of the function on the left-hand side. And again, delta x, using the value of the function on the left-hand side. And again, delta x, or the height of that rectangle, using the value of the function on the left-hand side. So here we do have 4 times -6 squared, don't forget to put in parentheses, otherwise you'll get the wrong number, minus 36, plus 4 times, again, don't forget to put that -2 in parentheses, squared, minus 36, plus 4 times, this one doesn't require parentheses this time, minus 36. So here we have 4 times 0, so that will provide us with 0, plus 4 times 4 minus 36, and then plus another 4 times, this will give us the same value, 4 minus 36. Note that 4 minus 36, that is a -32. 32 times 4, right? We got 32 times 4, 128. Okay, and then if we multiply that by 2, that's going to be 256 square units. So again, if we're doing a left-hand approximation in this case, okay, we have 256 square units. We wouldn't be able to tell overall if this value is a over approximation or an under approximation, since some points on this interval the graph is decreasing, while at other points on this interval the graph is increasing. And if we revisit this for a second, I did forget that that area is going to be negative. I forgot my negative sign because that area is under the curve. Anytime the area is, your graph goes below the x-axis, the area is just going to be negative in terms of what we're looking forward to later on with integrals. Let's do the same thing here in terms of dealing with our right-hand approximation. We're doing the same thing, but dealing on the right-hand side. So here our area is going to be approximately, again, delta x, and this is going to be f of negative 2, because now in the first subinterval, we're using negative 2 or the one on the right. So we have the area going in this direction over here, okay, and plus another delta x. This is going to be f of 2 for our next rectangle, okay, and then plus delta x, and now this one's going to be f of 6. Notice that that is going to be 0. Okay, continuing through, notice that we're getting very similar results from before. We have 4 times, this is going to be 4 or negative 2 squared minus 36 plus 4 times, again 4 minus 36, and plus 0. So again, negative 256 square units. So we're actually getting the same value whether we did a right-hand approximation or a left-hand approximation, which kind of makes sense because on one side it's decreasing, on the other side it's increasing, and we're symmetric to that line of symmetry, so it should be the same on both sides. Let's do the same concept, but now let's just practice one more time using that midpoint approximation. Remember the midpoint, we're just using the value right smack dab in the middle of each of those intervals. Our first interval going from negative 6 to negative 2, so that value in the middle will be a negative 4. So my first rectangle will have an area of delta x, f of negative 4. For my next rectangle, from negative 2 to 2, that midpoint will be 0, right? So again, the rectangle there from 0, okay, will go all the way down to the end and have that height that comes from, or that value that comes from f of 0. So we have plus delta x, f of 0. Plus the last rectangle coming in from 4. Okay, 4 is the midpoint of 2 and 6. And using that value, the function there at 4, to give us the value of the rectangle, how far down it goes. So therefore, again, we have delta x times f of 4. That is the value for our area approximation. So again, we have 4 times. Don't forget, in this case, your negative 4 would go in parentheses, minus 36, plus 4 times. We have 0 squared minus 36, and then we have plus 4 times 4 squared minus 36. If we approximate the first one here, we have 4 times 16 minus 36, plus 4 times a negative 36, and 4 times, again, that 16 minus 36 again. 16 minus 36, that is going to be a negative 20. So we have a negative 80 when multiplied by 4. We have another negative 80 at the other end. And then we'll have a negative 144. So combining those values, okay, we have negative 160 and negative 144. That is going to be negative 304. That looks good, square units. Okay, so this is going to be a better approximation to our curve here in terms of looking at those values and the midpoint.